this problem. So, did anybody choose to do substitution since we had the y by itself? Raise your hand if you chose substitution. Did anybody do elimination and you added the two equations together? Strangely, you could do elimination, but it looks really weird. It doesn't look like the problems where we have them lined up. But you could add the left side to the left side and the right side to the right side. And because you have a positive y and a negative y, you could do that. But I'm going to do substitution because when you see the y by itself, that should be your first thought. After that, I'm going to check my answer by graphing. So I'm going to take the 2x minus 1, and I'm going to substitute that for the y. So when I write the second equation, I'm going to write 3x minus, and instead of the y, 2x minus 1, and then equals 5. So the only thing I changed in the second equation was I changed the y to be 2x minus 1. Jeffrey, I'm going to have you close that. Thank you. AJ as well. All right, so remember to distribute that minus. So the 3x and then minus 2x. But minus minus is going to give you what? A plus. Good. Plus 1. And then combining like terms, you get how many x? 3x minus 2x? Just 1x, right? Plus 1 equals 5. And then get x by itself by subtracting the 1. All right, so we get x equals 4. And then we can substitute into either equation. How many people would like to substitute in the first equation? Does the first one look better? How many want to substitute in the second equation? I had one vote for the second equation. Are you guys going to let it go to the second equation with one vote? First equation, how many votes? One vote. Second equation? You're going to vote twice? Okay. I'm doing the second equation because you guys told me to, but honestly, the first equation is so much easier. So second equation, you have 3 times 4 minus y equals 5. And then 12 minus y equals 5. How do I get rid of the positive 12? Subtract it, yes. Negative y equals negative 7. So what does positive y equal? 7, right. You can divide it by negative 1 if you want to show it mathematically, but if negative y equals negative 7, it makes perfect sense that y equals 7. And then write your answer as a point.
Can you substitute it to the first equation?
Yes, wouldn't that be easier?
Yeah, but I got one.
What did you get?
I got one.
So if I put 4 into the first equation, 2 times 4 is 8, minus 1 is 7. Okay. All right, so I did say that we could skip problem 2 because we had already done a warm-up on the boards. So we're going to move on to, actually, I wanted to show you how to check this one in on your calculator. So what we do have to do, if we want to check it on your calculator, is get the y by itself. And since I'm not doing this problem, I'm going to take this equation over here, and I'm going to get y by itself. So I had 3x minus y equals 5. To get the y by itself, I could subtract the 3x. Negative y equals 5 minus 3x. And then divide by negative 1. Negative 5 plus 3x. So remember what we're doing now is we're checking by graphing. So I'm going to graph this equation, and I'm going to graph that first equation right there. If you don't have your graphing calculator on your desk, please get your graphing calculator so that we can graph this. So we're checking our answer. We're going to put in 2x minus 1, and then go down to y2 and put negative 5 plus 3x. Does anybody want help finding the buttons to put that in the calculator? Okay. All right. Step 1, get y by itself. What work do I have to do to get y by itself? No work, right? Because it's already by itself. So that means that if this equals y and this equals y, they equal each other. So I can write x squared plus 3x minus 4 equals 2x plus 2. Did you get that? Good. Now, we need to make one side 0, and you want to keep your x squared term positive. So whatever side your x squared's on, if it's positive, leave it there, and then move everything else. So I'm going to get rid of this 2x by subtracting it, and then also from its like term. And get rid of the 2 by subtracting it, and also from its like term. All right, combine the like terms. And then consider whether it's factorable. Not every quadratic equation is factorable.
Wow. It does have an exponent. We don't need this.
All right, I need two numbers that multiply. Yes.
It does have an exponent. We need,
Let me come and see you in just a minute. Two numbers that multiply to -6 and add to 1. Find those numbers and then factor it and solve it. Good collaboration there. Most of you found that the numbers were -2 and what? -2 and +3. So, write your factors. For the -2, you write x minus 2. For the +3, you write x plus 3. So remember I told you factoring comes back. Now if those two factors multiply together to make 0, that means one of them has to be 0. So set each one equal to 0.
you know what else? That'd be 2. Oh, so
Now,
are you up for it?
it seems like we've done a lot of work. We should be done. But we have two x values and we don't have any what? Y's. Yeah, we don't have any y values. So we have to find y values. Is it going to be easier to substitute back into the quadratic or the linear? The linear is almost always going to be easier, so I'm going to substitute into that. It works with both of them. You could choose either one, but I'm going to choose the linear. So I'm going to have two different sets of solutions. I'm going to put 2 back into the linear, y equals 2, and then instead of the x times 2, plus 2. You guys get 6? Okay. All right, so when x is 2, y is 6, so that point is 2, 6. And then you do the same thing with the -3. I'm going to still put it in the linear equation because that's easier. There's no reason to switch to the harder equation. So y equals 2x, so 2 times -3 plus 2. Okay, so -6 plus 2, you guys getting -4? So when x is -3, y is -4. There's two solutions. Oops. So what happened is you had a parabola, and a line crossed through that parabola in two different places at those 2 points. I'm going to help you get started with another problem, and then give you guys a little time to work on it. These problems are getting a little bit longer. So if you need some scrap paper, I have some on the shelf over here so that you don't have to like write all over all the other problems. Okay. All right, here's my first equation. I need to get y by itself. It seems difficult, but it's actually not. All right, so to get y by itself, I'm just going to subtract the x squared, subtract the 3x, and add the 2. See, because I'm doing opposite. And then over here on the other side, subtract x squared, subtract 3x, and add the 2. So that cancels, that cancels, that cancels, and I get y equals this. So I had to get y by itself. And so I moved everything to the right side. That was my first equation. All right, my second equation is x minus y plus 6 equals 0. Now I could subtract the x and the 6 again, but I would be stuck with negative y. So you can do it that long way if you want, or you can realize I could just add y to both sides, and then I'll have y by itself. So because this is a negative y, I can just add y, like that. And then I get, this cancels, x plus 6 equals y. All right, so they both equal y, so that means they equal each other. So I'm going to set this equal to this. It really doesn't matter which one you write on the left and which one you write on the right, but I'm going to write the x plus 6 on the left, and then this one on the right. So we have to get everything to one side, and it might seem shorter to subtract the x and subtract the 6, but then I'll be still left with a negative x squared. And you don't want to be left with a negative x squared. So instead, I'm going to move everything from the right side to the left side so that I can have a positive x squared. So I'm going to add x squared here, and there's no like term, so I'm going to just add it right here. I'm going to add the 3x, and I'll add it to its like term x. And then I'm going to subtract the 2. And that's going to make my right side equal 0. And then my left side is going to be x squared plus 4x plus 4.
Miss Bro,
Yeah.
you have tissues?
No, just the paper towels. I feel like I have a typo somewhere. Do you guys see if I have a typo? Oh, I think that I got changed on this one. So maybe I don't have a typo. Oh, here it is. Okay. No, I thought I copied something wrong, but I didn't. All right, so now we're looking for numbers that multiply to 4 and add to 4. What are two numbers that both multiply to 4 and also add to 4?
2.
2 and 2, yes. So we get x plus 2 times x plus 2. And notice that they're going to give us the same answer. So I'm going to set them equal to 0, but they're going to give us the same answer. So subtract the 2, and we get x equals negative 2. So this time we're only going to get one solution. We do have to put it back in, so I'm going to put it into this equation right here. The x plus 6 equals y equation. And then negative 2 plus 6 equals y, so y equals 4.
I already did.
All right, we're gonna do problem 3 as our last problem. So take a look at problem 3. Remember, you're gonna start by getting y by itself. I want you guys to try to get started on it, and I'll come around and see who needs help. All right, so just to let you know, this procedure that we're following will always work, and I'm gonna show you with the procedure because I think a lot of people like to have one way to do a problem. However, Levi and Armando discovered that they could also just substitute negative x minus 10 directly for the y here. And so that's just substitution like we did on the last lesson. That can work too. But the directions I'm going to follow instead, though, are to get y by itself. So this y is already by itself. For this one, I'm going to keep this y positive, and I'm going to subtract x squared on both sides and add 2 on both sides. So I get y equals negative x squared plus 2.
You okay, I saw?
So y equals this one, and y equals this one, so I'm going to set them equal to each other. All right, so these two equal each other, so I have negative x minus 10 equals negative x squared plus 2. I really want the x squared to be positive so I can factor easily, so I'm going to add the x squared to both sides. Now notice I didn't put it under the x because they're not like terms. And then I need to get rid of the 2 as well, so I'm going to subtract that and put it under its like term. So the x squared has nothing to add to, so I just bring it down. The negative x has nothing to add to, and then negative 10 minus 2 is negative 12. So if you haven't factored yet, you are looking for two numbers that multiply to negative 12 and add to negative 1. Okay, so go ahead and factor that, and then set your factors equal to 0. You should find your x values. Numbers that multiply to negative 12 and add to negative 1 are negative 4 and what? 3, thank you. So I have x minus 4 times x plus 3 equals 0. All right, set each one equal to 0. And solve. So I get x equals 4. Okay. After we find both x's, what do we have to find? The y's, yep, the y's. All right, so I told you I was going to skip problem 4, so I'm going to use this space up, okay? So x equals 4, x equals negative 3. I'm going to substitute, nope, actually not that one. I'm going to substitute into my linear equation. Y equals negative x minus 10. Y equals negative 4 minus 10. So I get y equals negative 14. Just 1 minute. I'm going to use this equation again. Y equals negative x minus 10 and substitute negative 3 in. What happens when I have negative 3? It becomes positive 3. So I get negative 7. All right, so remember, that's not problem 4. We're not doing problem 4. That's just the continuation of problem 3.